Jai Jagannath. So welcome to More Physics. So today we will start new chapter, that is chapter 22 of University Physics book. That is topic of discussion is Gauss law. So before going to start Gauss law, let us first discuss what is area vector. What is area vector? You see, we have read in the vector chapter. So classification according to scalar quantity and vector quantity, we have taken area, volume, everything is scalar quantity. But if that area is represented by a vector quantity, so definitely it must have some direction. So how will find the direction? Suppose you see this is a circular disc. Okay, let us say the circular disc of radius r. So this disc, suppose this is the disc whose radius is r, and this disc is lying on which plane? On this board. Then what is the area? So here the magnitude of the area is pi r square. But this disc is lying in which plane? In the board. Suppose this board has, this is x-axis, this is y-axis. That means this disc is lying in the xy plane, whose area is pi r square. Then what is area vector? So area vector is always perpendicular to the area element. So this is the disc, and this is the area of the disc, and here area vector is perpendicular. The area vector is perpendicular to this area element, that is disc. So this is the direction of the area vector. And what is the magnitude of this area vector? Magnitude of the area vector is pi r square. Now you see, if this disc is lying in xy plane, then perpendicular to this disc is either positive z-axis or negative z-axis. So we can say the area vector has magnitude as well as direction. So here what is the magnitude of the area vector? If the radius is r, pi r square, and a cap is the unity vector perpendicular to the area element. So unity vector perpendicular to the area element is the unity vector along which axis? Z axis. And what is the unity vector along z axis? K cap. So this is the area vector of this disc. Or we can say we can take also the negative z axis is also perpendicular to this area element. And you see, this disc is which dimensional figure? Disc is two-dimensional figure. So here either the perpendicular is upward, that is in positive z axis, or the perpendicular is along negative z axis. So if I will take the negative z direction perpendicular, then I can say the area vector is equal to the magnitude of the area pi r square, and it is acting in negative z direction, whose unit vector is minus k cap. So this is called area vector. So you may write area vector. Definition of area vector. Area vector is always perpendicular to area element. Perpendicular to area element. Okay. Now let us take another example. Suppose this is your x, this is y, this is the z axis. So you take a rectangular plate. Let us say this is the rectangular plate. The length of the rectangular plate is A, and breadth of the rectangular plate is B, and this plate, this two-dimensional rectangular plate is lying in which plane? XZ plane. Then what is the area vector of this rectangular plate? So here I can say the area vector of this rectangular plate, area vector of which plate? Rectangular plate. In this rectangular plate is lying in which plane? XZ plane. In XZ plane is equal to, first any vector has magnitude. What is the magnitude of the area? Length into breadth. This is the area. And the perpendicular to this aerial element or rectangular element is along which axis? Either positive y-axis or negative y-axis. So if it is in positive y-axis, so I can write it is ABJ cap. Or we can write the area is AB and perpendicular in negative y direction, it is your minus J cap. So this is the area vector of the rectangular plate. Suppose take another example. Let us say this is X plane, this is Z plane, this is Y plane. So you take a square of side B, and this plane, this square plane is lying in which plane? XZ plane. So if so, then what is the area vector? So area vector of this square plane is, what is the magnitude of the area? It is B into B, that is B square, and it is lying in SZ plane. So to SZ plane, which vector, which axis is perpendicular? Y axis. So along positive Y axis, I can write it is J cap. Or area vector can be written as B square minus J cap. Always remember, area vector is perpendicular to the area element and it is outward. Always the direction is outward. So if it is two-dimensional plane, then the direction is either upward or downward. There may be two possibility of direction of the area. Now, area vector in 3D surface, that is closed surface. For example, if you take a cylinder, you see this cylinder is a three-dimensional figure. So it occupies volume. So now this is your three-dimensional surface, that is take a cylinder. In the cylinder there are you see there are two sides here, this base and top. So this is circular area. So here area vector is perpendicular to the surface. Here area vector is perpendicular to the surface. You see there are this end and this end. So area vector is always perpendicular to the aerial element. It is always outward. So here A1 and A2 are the area vector in these two surfaces. And there is a curved surface, you see. There is a curved surface. So here area vector is always perpendicular to the surface. Always perpendicular to the surface. So for a three-dimensional element, the area vector is always perpendicular to the surface. Now see, let us take a cube. Let us take a cube. So in the cube, so you see, let us say this is a cube. There are 6 surfaces. This surface, upper surface, bottom surface, this side 2 surface. So how many surfaces are there? 6 surfaces. So the area vector is always perpendicular to the aerial element. So here this is one area vector, this is another area vector, this is another area vector, this is one area vector, this is another area vector, and the bottom is also another area vector. Always area vector are perpendicular to the surface and it is outward. So now if you take a sphere, solid sphere, in the solid sphere, if you just cut, you will get a circular disc. And what is the area vector? Area vector is perpendicular either in this direction or in this direction. Similarly, if I cut in this way, the area vector is perpendicular. So mark it, area vector is always radially outward direction. For a sphere, area vector is always radially outward direction. So this is about the area vector. Now we will discuss the electric flux. What do you mean by electric flux? The flux symbol is phi, and since we are discussing electric flux, we are writing phi E. So phi is flux, E stands for electric. So this is your electric flux. So what do you mean by electric flux? So before going to discuss the electric flux, let us know what is lines of force. What is lines of force? Now you see, suppose we will take a charge Q. I will take a charge Q. So this is called source charge. You just keep a unit positive test charge here. If you just keep here, it will not stay at this point. It will move. Along which line? Since the source charge I have taken positive, so this positive will repel this plus 1 along which direction? This is along this direction. So this is the line on which a unit positive test charge will move freely under the presence of a source charge Q. And this line is called lines of force. This line is called lines of force. And if I will keep a positive charge here, this positive charge will never remain here. It will move freely in which line? This line. So this is also called lines of force. So from the definition it indicates lines of force is that force on which lines of force is that line on which force acts. Since it is a charge, so charge is nothing but the charge of an electron. So it is called electric lines of force. Okay, so this is called electric lines of force. Just imagine, suppose you take a water pipe. So this is the water. So this is, let us say this is the valve. If you open the valve, what will happen? If you open the valve, what will happen? Water will come out from the surface of this tap. So each lines of water is called lines of force of water. Lines of force of water. And the set of lines of force of water passing normally is called water flux. Is called water flux. So if you will see, if you will open the tap and you will see water will come out. If you will see through a microscope, the total water consists of various lines. So that lines is called lines of force of water. And the set of lines of force of water passing normal to the surface of the tap is called water flux. Then just take an example. Suppose this is a torch light. This is the bottom. You just switch on this torch light. What will happen? The ray will come out from the surface of the torch light. And each ray is called lines of force of light. Lines of force of light. And if you will take a set of lines of force of light, a collection of the lines of force of light passing normal to the surface area, passing normal to the surface area is called light flux. Light flux. So set of lines of force is called flux. If it is light, it is called light flux. If it is water, it is called water flux. If it is electric lines of force, if it is electric lines of force, then set of electric lines of force passing normal to the surface area is called electric flux. Is called electric flux. So electric flux phi E. So definition of electric flux. What is electric flux? It is set of lines of force. Which lines of force? Electric lines of force passing normal to the plane surface is called electric flux. Is called electric flux. Now you see, suppose you take a point charge body, point charge. So due to this point charge, what will happen? The lines of force will start moving like this, okay, in this direction also. Suppose I will take the charge value, for example, the charge value is, let us say, 5 coulomb. So this is the lines of force, okay. So here what happens, I will take another charge particle whose value is 20 coulomb. So here what will happen, the lines of force is very crowded. So these are called lines of force. That means here charge is less, here charge is more. If charge is less, electric field intensity is less. If electric field intensity is less, lines of force, the number of lines of force is also less. If number of lines of force is less, then electric flux is also less. So here the magnitude of charge is more, so electric field strength near to the charge is also more. If electric field intensity is more, then number of lines of force is also more. That implied flux is also more. Okay. So now, what is the conclusion? Conclusion is that the flux, that is electric flux, is directly proportional to the electric field strength. So E is what? Electric field strength. If electric field strength is more, then flux is more. You see, in case of torchlight, if the battery power is more, if the battery voltage is more, then more light will come. That is, intensity of light will be more. If intensity of the lines of the light is more, then light flux is more. Similarly, in the water tube, if the head of the tank is more, then the high amount of water will come out. So here the water flux will be more. So the flux depends upon the strength. That is, strength depends upon the source. In case of electric lines of force, the electric flux is directly proportional to the electric field strength. So if electric field strength is more, flux is more. Okay. So flux depends upon electric field strength. Another factor is that you see here you say, let us say, for same charge you take a small area here. So here what is the number of lines of force passing through this small element? 1. Now I will take a bigger area. If the area increases, what will happen? The number of lines of force will also more. Here small area, 1 lines of force was passing. Here more area, number of lines of force passing is more. That means if number of lines of force is more, flux is more. So what is the conclusion now? The electric flux is directly proportional to the area. I think it is clear. So mathematically we can write the expression of flux. Just like momentum depends upon mass. Momentum depends upon velocity. Then how can you write the momentum? Now it is the product of mass and velocity. Here similarly, mathematically we can write the electric flux is equal to the product of E and EA. E is the vector, and area, we are representing area is also a vector. So the dot product of E and A, that is electric field and area vector, is equal to electric flux. Okay. So or we can say electric flux is equal to, the magnitude of electric flux is equal to EA cos theta. Then what is theta? Theta is angle between electric field vector and area vector. So theta is angle between electric field vector and area vector. Okay. So from the name it indicates, you see, flux, the expression of the flux is equal to E dot A, provided this is under what condition? If electric field is uniform. What do you mean by uniform electric field? The lines of force are parallel to each other and they are equally spaced. They are equally spaced. So this is the uniform electric field. For uniform electric field, the electric flux is equal to E dot A. Then for non-uniform electric field, what is the formula? For non-uniform electric field. So what is the flux? So here first you have to calculate the small electric flux in small area, that is dA. So in the small area we can assume electric field intensity is constant. So for small area dA vector, the flux passing is very small, that is d phi e. Then total flux phi is equal to what? The integration of E dot dA. And this integration is not line integral. It is called surface integral or closed integral. This circle sign over this integral sign indicates it is which integral? Surface integral. Or you can say closed integral. Closed integral. So surface integral of E dot dA is equal to electric flux. This is under what condition? For non-uniform electric field. But for uniform electric field, you can directly write down E dot A. Now, what is the unit of flux? What is the unit of flux? So definitely flux is which quantity? Scalar quantity. Why flux is scalar quantity? Because it is dot product of two vector. And what is the unit of flux? Unit of flux. You see, E dot A is electric field intensity. What is electric field intensity? It is force per unit charge, that is Newton per coulomb, into area. Area is meter square. So this is the unit of flux in which system? SI system. We are generally taking SI system. Then another formula is that now unit of flux is Newton per coulomb per meter square. Since you know electric field intensity is nothing but negative potential gradient. These things we will discuss during the potential class, or it is already known in the 9th, 10th class, 10th electrical subject. So E is equal to negative potential gradient, that is dV by dr. So what is the unit of electric field intensity? dV means potential difference, whose unit is volt. It is distance, meter. So now unit of electric flux can be written by, you see, what is the formula of flux? E A cos theta. So what is the unit of E? Volt per meter. Area is meter square. Cos theta has no unit. So another unit of the flux is voltmeter. This is one unit, or this is Newton per coulomb into meter square. So now let us solve a problem. You see, let us say this is the, suppose you take a disk. So the area vector is perpendicular to the disk, and this is the radius. And let us say the electric field intensity is making 30 degree with this line. So what is the, so question is, if R is radius, now see, suppose you see this is a disk whose radius is R, and here the perpendicular to the disk is which vector? Area vector. So area vector is perpendicular to the disk, and here there is an electric field. You see, this is an electric field. So the this red pen indicates the direction of the electric field, this blue indicates the area vector, and this electric field is making 30 degree with the radius vector. Okay, so we have to find what is the flux through this surface. So what is the formula here? Tell me what is the angle between electric field and area vector. This is electric field and this is your area vector. Area vector is always perpendicular to the element. So this is area vector, this is electric field. So this angle, this is the angle which is angle between what? Area vector and electric field. So this angle is what? 90 of the 90 minus this angle. So this angle is 30 degree. So what is the angle between area vector and electric field? It is 60 degree. So here we can say the theta, which is angle between area vector and electric field vector, is equal to 90 minus 30, which is equal to 60 degree. So now what is the flux? So flux is equal to, electric flux is equal to E dot A. That is EA cos theta. E is what? It is only given E. Area is what? Radius is R. So pi R square. Cos theta. Theta is not 30 degree. Many students put here directly 30 degree. No. Theta is angle between the electric field and the area vector. That is 60 degree. Cos 60 is half. So half pi E R square is the area, is the flux. So you see, let us solve example 22.1. What is the electric flux through the disk? You see, this is a disk given whose radius is 0.1 meter and electric field is given in horizontal direction. What is the strength of electric field? 2 into 10 to the power 3 Newton per coulomb. This is uniform electric field. So now you see the area vector whose direction is given perpendicular to the area element, that is this unit vector is the unit vector of area vector which is perpendicular to the area, and this unit vector, that is area vector, is making 30 degree with electric field vector. So first bit, what is the electric flux through the disk? So first bit, what is the electric flux through the disk? So what is the formula of electric flux? It is E dot A or EA cos theta. So what is E? 2 into 10 to the power 3. All are in SI system. Area is pi R square. Pi into 0.1 square into cos theta. Theta is what? Theta is angle between electric field vector and area vector. This is the unit vector of area. So that means theta is equal to 30 degrees. So just directly put all the values. So you will get the value 54. And what is the unit of electric field flux? Electric field intensity is Newton per coulomb. Area is meter square. Then come to second bit. What is second bit? What is the flux through the disk if it is turned so that n cap is perpendicular to the electric field? So this is the electric field, and here in the second case the unit vector of area will be perpendicular to the electric field. That means this disk is rotated like this. This disk is now in horizontal direction, so that the area vector, that is unit vector of area, is now perpendicular to what? Electric field. So here theta is equal to what? 90 degree according to the question. The unit vector is perpendicular to the electric field vector. Then in this case, what is the flux? So flux is equal to E A cos theta. Theta is 90 degree, so 0. That means if the element, the plane of the element is along the direction of electric field, then no flux will pass. So flux will be 0. For example, you see, this is the disk. If you see, this is the disk, let us say this is the disk. So here area vector is this. Okay, area vector is, okay. So I am taking, let us say this is the area vector of the disk and this is the electric field. So here theta is 90 degree, flux is equal to 0. That means when the lines of force are tangential to the surface, there will be no flux. I repeat, when the electric field is just parallel to the surface, just lying on the surface, so there will be no flux. But if the area vector is making certain angle with the electric field, there will be flux. Okay. So now come to third bit. Come to C bit. What is C bit? What is the flux through the disk if n cap is parallel to the electric field? Parallel to the electric field. That means if we will keep the plane of the disk like this, and it is already given the direction of electric field is here, and here the n cap, which is the area vector, is parallel to the electric field. So in this case, what is theta? Theta is equal to 0 degree. If theta is equal to 0, what is the flux? Flux is equal to EA cos 0. So E is given 2 into 10 to the power 3. Area is given pi into 0.1 square. Cos 0 is equal to 1. Calculate this. You will get 63 Newton per coulomb meter square. So this is the value of flux. And in this condition, flux is maximum because cos 0 is equal to 1, that is maximum. So you will get maximum flux. Under what condition you will get maximum flux? If this is the area vector, okay, and along the area vector, if there is electric lines of force, if the electric field is parallel to the area vector, more flux will pass. That is, lines of force must be perpendicular to the area, perpendicular to the area element. In that case, flux is more. You see, let us discuss example 22.3. A point charge Q 3 microcoulomb is surrounded by an imaginary sphere of radius 0.2 meter. You see, suppose this is a sphere, not a circle. This is 3D figure. Huh? So this is a sphere. So at the center there is a charge Q. What is the value? 3 microcoulomb. And you take an imaginary sphere of radius r, which is equal to 0.2 meter. So question is, what is the flux through this surface? This is 3-dimensional surface. And I have told for a sphere, the area vector always lie along the radial line. Or you can say the area vector. Suppose I will choose a small area here. Just imagine football. On the football surface, you take a small element. And if you will draw the perpendicular to this small element, so that small element will lie along which line? Radial line. Let us say this small element area is dA. So dA is the area of small element on the surface of imaginary sphere. Okay, small element. So and what is the radius? Radius is 0.2 meter. What is the charge? Charge is 3 microcoulomb. So now we have to find what is the flux through this small element. Since the element is very small, the flux passing through this small element is also very small. So that very small flux is equal to d phi e. So this d phi e is nothing but E dot dA. What is E? E is electric field intensity on this surface due to presence of this charge Q. So this is a point charge. And what is the distance between this charge with this point? That is 0.2 meter. And we know for a point charge, what is the formula of electric field intensity? K Q by R square. Okay. And since it is the positive charge and electric field intensity at this point is always away from the positive charge, or if you will keep a plus 1 charge here, this plus 3 microcoulomb will repel this plus 1 along this direction. So this is the direction of the electric field intensity at this point. And this is the direction of the area vector also. So what is the angle between the electric field and area vector? 0 degree. So I can write E dot dA is equal to E into dA into cos theta, theta is equal to 0 degree. So that is equal to, what is K? K is equal to 1 upon 4 pi epsilon naught. We are assuming it is air sphere, air medium, no other medium. 1 by 4 pi epsilon naught. And what is the value of Q? Q is equal to 3 microcoulomb, 3 into 10 to the power minus 6, divided by r square. So keep r square as it is. Why as it is, I will say later on. Okay. So this is kq by r square dA. Cos raised 1. So this is what? The small flux passing through the small area. But I want to find the total flux coming out the whole sphere. So what I will do? I will integrate this d phi e. Which type of integration? We will integrate over the total surface. That is surface integral of this d phi e is equal to total flux, which is equal to surface integral of, you see, 3 into 10 to the power minus 6 divided by 4 pi r square into epsilon naught. What is epsilon naught? 8.854 10 to the power minus 12 in SI system. You see, 4 pi r square epsilon naught is this into dA. Now you see this value, you see this r is radius, that is constant. So everything is constant. And you see on the whole surface of the sphere, electric field intensity at each point on the surface is constant. Electric field intensity magnitude is constant over the whole surface of the sphere, because you know, suppose in a football, if you keep a charge at the center, from center to the point, any point on the football surface, the distance is same, charge is same. So electric field intensity everywhere remains constant. So this electric field intensity is constant in the every point on the surface. So this is constant. So only you have to integrate the area. So what is the integral of dA? The integration of dA is equal to area, total area. So that implies total flux is equal to, we will multiply later on, this is 4 pi r square 8.854 10 to the power minus 12 into integration of dA is equal to area. And what is the surface area of this sphere? Surface area of this sphere is 4 pi r square. So this 4 pi r square cancel. So if you calculate the total flux, so it will come 3.4 10 to the power 5, and since it is flux, Newton per coulomb meter square. So this is the answer. And always remember, if charge is positive, if the lines of force is coming out from the surface, then flux is positive. But if the lines of force, suppose you see, suppose this is the lines of force, this is the direction of electric field or lines of force. If the lines of force is towards the body, towards the surface, then here flux is taken to be negative. So flux is taken to be negative if the lines of force is coming into the surface, and flux is taken to be positive if the lines of force is coming in out from the surface. Why so? You see, suppose this is the closed surface and area vector is always away from the surface. But if the electric field is inward, and area vector is outward, so theta is what? 180 degree. Suppose area vector is outward, electric field is inward, then what is the angle? Angle is 180. So cos 180 is equal to negative, so flux will be negative. But if the electric field is outward, area vector is always outward, so here theta is equal to 0 degree. In that case, flux will be positive. So let us solve this test error understanding 22.2. Here, rank the following surface in order from most positive to most negative electric flux. There are 4 cases, and you have to find flux in each case Then you have to order from most positive to most negative. First bit. In the first bit, a flat rectangular surface with surface area given 6 I cap meter square SI system in uniform electric field of 4 J cap Newton per coulomb. This is area meter square. So here first find out the flux. So flux in first bit answer is equal to what? E dot A. So E is equal to 4 J cap dot area is 6 I cap. So that is, and you know J dot I is equal to what? 0, because so here 4 into 6 into A dot B is equal to AB cos theta. So here theta is angle between I cap and J cap. So here I cap is unit vector along x axis, J cap is unit vector along y axis. So the angle is 90 degree. That is cos 90. AB cos theta. Cos 90. So flux is equal to 0. Now come to second bit. In the second bit, a flat circular surface area. So it is a circular surface whose area is given 3 J cap meter square, and it is come across by an electric field, uniform electric field of 4 I cap plus 2 J cap Newton per coulomb. So you have to find the flux, in which case? Second case. So simply E dot A. Just take the dot product, you know, in the vector algebra. So 4I plus 2J dot 3J is equal to, so I dot J is equal to 0, J dot J is equal to 1. So 2 3 is 6 Newton per coulomb meter square. So this is the second case. Come to third case. In the third case, a flat square surface with area vector given 3 I cap plus 7 J cap new meter square, and electric field vector is given 4 I cap minus 2 J cap. So what is the flux in third case? So E dot A. So here 4 I cap dot 3 I cap is equal to 4 into 3, 12. So plus 7 minus 2, 14. J dot J is 1. So that is equal to how much? I think it is minus 2 Newton per coulomb meter square. Then come to fourth bit. In the fourth bit, electric field intensity vector dot A vector. So that is flux. Flux in fourth case, E dot A. E is equal to what? 4 I cap minus 2 J cap. Dot area vector is what? 3 I cap minus 7 J cap. Just take the product. So 4 3 is 12. Minus minus plus 7 2. 14. That is 26 Newton per coulomb meter square. So what is the answer? Answer you have to write from most positive to most negative. So this is one value. This is a second, third bit answer. This is second bit answer. This is first bit. So the most positive is 26. That is fourth bit. Then 6 Newton per coulomb. That is second bit. Then third is 0. Third is 0. That is first bit answer. Next is negative. Negative is third bit answer. So this is the, so see, this is a cube of side L. The cube of side L. And this cube, so there is an electric field which is horizontal. Okay, they along x axis. And these two sides, that is this side, side number 3, surface 3 and surface 4 are parallel to the electric field. Two faces are parallel to the electric field. So we have to find the total flux in this cube. So in the cube, how many surfaces are there? 6. So top and bottom 1 and 2. This side 3 and 4. And the back side is say 5. And this front side is say 6. Sixth surface. Okay. So now what is the flux? So flux, the total flux is equal to flux from first surface, flux from second, third, fourth, fifth and sixth. So what is phi 1? You see, here electric field is horizontal and area vector is perpendicular. So for first surface, angle between area vector and electric field is 90 degree. So what is the flux? E A1 cos theta 90 degree. What is phi 2? Electric field is horizontal, area vector is perpendicular but downward direction. So what is theta? 90 degree. So flux in the second surface is equal to EA2 cos 90. Then phi 3. What is flux phi 3? Here area vector is towards left, electric field is towards right. So angle between area vector and electric field is 180 degree. So we can write EA3 cos 180 degree. Plus what is phi 4? Flux through the fourth surface. So here area vector is towards right, electric field is also towards right. So the angle is equal to 0. Plus fifth surface. You see fifth surface. So fifth surface is perpendicular to the surface in backward direction and area electric field is horizontal. So angle between A5 area fifth area vector and electric field is 90 degree. So you can write EA5 cos 90. Similarly, for sixth surface, that is this front side. So here in the front side, this is the area vector perpendicular to the surface. Electric field is horizontal. So again the angle is 90 degree. So this is cos 90, 0. 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 So the total flux is equal to EA3 cos 180 is minus 1 plus EA4 cos 0 is 1. So that is equal to, so here A3, what is area? This is a cube, na? So if it is a cube, the area is equal to what? A3 is equal to A4 is equal to L square. So we got minus EL square plus EL square, which is equal to 0. So total flux through this cube surface in presence of horizontal electric field is equal to 0. Okay. Now you see why in third surface flux is negative. Here electric field is coming into the surface. For third surface, electric field is coming into the surface. That's why it is negative. And in the fourth surface, electric field is out from the surface, away from the surface. So area vector is away. Electric field is also away. So here flux is positive. But the total flux is equal to 0. So next class we will start Gauss law. So how to calculate the flux in a closed surface using Gauss law. So that will be discussed in the next class. Okay, bye.